are Group 11 from second year BTECH CSE Panel K, and today we are going to explain the topic TLS protocol. My name is Amrit Kumar Jha. The topic explained by me will be working and applications.
So as after Amrit has explained his topic and explanation, my topic was details of the TLS protocol such as rules, commands, type of messages, in which layer it works.
Everyone has been explained by Bilal and Amrit. My part, being part of Group 11, will be to explain the implementation, the application, and the alternatives which are used in the real life world examples or applications instead of TLS protocol.
What is a TLS? Transport Layer Security or TLS is a widely adopted security protocol for data privacy and security for communication over internet. TSL is used for encrypting the communication between the web application and server, such as a web browser loading a website. TSL is also used for encrypting other communication such as email, messaging, and voice over IP. TLS was proposed by Internet Engineering Task Force and was published in 1999. The most recent version of TLS is 1.3, published in August 2018. TLS was evolved from an encrypting protocol named Secure Socket Layer (SSL), which was published by Netscape. TLS version 1.0 actually began development as SSL version 3.1, but its name was changed before the publication in order to indicate it was no longer associated with Netscape. Because of this history, the terms TSL and SSL are sometimes used interchangeably.
Next, we will be talking about the details of the TLS protocol. In this TLS protocol, we have so many points. Some of the points I will be summarizing are such as rules of the protocol, commands, type of messages, and in which layer it operates. So let's see. First of all, we have the rules of the TLS protocol. One of the most significant rules in the TLS protocol is the handshake rule. The handshake rule is why it is so significant is because it establishes a secure connection between the client and the server. In the diagram, we can see that the client and the server have a secure connection, and there are so many commands given below to address the connection. Next, we have the commands of the TLS protocol. There are various commands of the TLS protocol to convey messages to the TLS protocol. Some examples I would like to give is such as client hello, server hello. Client hello proposes the connection, server hello accepts the connection. Then we can also see the certificate request, client request, certificate request, request client certificate. So client certificate, it sends the certificate. In the diagram we can see, next slide show you. In this diagram we can see the different client hello, server key exchange, client key exchange, and how it is operated. Next point I would like to show you guys is the layer, in which layer it is used. This is a very significant point of the TLS protocol because this TLS protocol operates in the session layer, which is in the middle of the application, and the transport layer, and that is why it allows us to secure any protocols such as HTTP, TCP, IMAP, FTP, and many more. And this is why the underlying transport protocols helps in the layer usage.
So as explained by my teammates Aditya and Bilal regarding the introduction, history, and details of a TLS protocol. Now let's see what is working of a TLS looks like. Working of a TLS basically depends on three principles. First, what is the TLS handshake? Second is the cipher suits and public key cryptography. Third is authentication and the integrity. Let's move on to what is the TLS handshake. TLS ensures secure communication between a client, that is a user device, and a web server. TLS handshake begins when a secure website is accessed, establishing a trust and encryption between the client and the web server. The version agreement. Client and server agree on which version of TLS to use. For example, there are many versions of TLS, example TLS 1.2, TLS 1.3 and TLS 1.4. Now let's move on to cybersecurity and public key cryptography. This is the most crucial step in mentioning the working of a TLS, the most important principle that we require for a TLS to work. Cyber suit in public key cryptography basically explain cyber suit, security recipe. It defines an encryption algorithm, integrity check, and a secure key exchange protocol. Now let's move on to public key cryptography. Public key cryptography ensures secure connection, key exchange over an unencrypted channel using public and private key. Server identity verification. The most important step overall, the cyber suit and public key cryptography is the most crucial part in working of a TLS. However, the most important step in working of a TLS in cyber suit and public key cryptography is server identity verification. The server uses a private key and the client uses the public key, that is TLS certified. Both the private key that the server uses and the client uses the public key, both the keys are TLS certified to verify the authenticity. Now let's move on to authenticity and message integration. The last step, last principle in the working of a TLS. Here we define three terms: server authentication, session key generation, and data integrity with MAC. Let's move on to server authentication. The server shares its public key through a TLS certificate so that client can verify its identity. Session key generation: after authentication, both client and the server generate shared session keys for secure communication. Now let's move on to data integrity with MAC. A message authentication code ensures the data wasn't tampered with during transmission. These three principles were the basic of how a TLS works. What does the working of a TLS explains. Now let's move on to a diagram to understand it through a diagram more easily. This is a diagrammatic representation of how a TLS works. So basically this diagram shows the TLS handshake over TCP. It starts with TCP three-way handshake, SYN, SYN, ACK and ACK. That is the acknowledgement request. Then the client and server exchange cryptographic information, which we have discussed in cyber suits and cryptography, which was the most important part in working of a principle, in working of a TLS. Here the cryptographic information are client hello, server hello, certificate, keys, etc. And it confirms the step that is finished to establish a secure connection. Thus, this diagram completely explains what does the working of a TLS, how does the working of a TLS does inside a transport sublayer. Now, the rest will be explained by Kapil. Thank you.
In this part of presentation, I will be talking about TLS, which is transport layer security. Not just what it is, but how it is used in real life application, real world application, and how it is implemented in the system, and what other protocols can be used in the place of TLS. So up to this part, it was explained by Mr. Amit Kumar Jha, Aditi Waq and Bilal. I hope you have better understanding of how it works and all those things previously explained in this slide presentation. So I will be talking about the application. So in application, there are many such applications in TLS, which is a backbone of secure communication over the internet. Whenever you use padlock icon in your browser, that's TLS at work. That means the TLS is at work at that point of time. It is used in wide range of applications like web browsing, then cloud security, mobile application, then VoIP and messaging, and VPNs, online banking and payments. So basically, TLS operates on 4 levels, but security application layer protocols like HTTP, which is hypertext transfer protocol, then SMTP, that is simple mail transfer protocol, and FTP. For example, HTTPS and HTTP communication between browser and server, it is encrypted by the TLS, that is transport layer protocol. Developer need TLS to set up the APIs, which we basically use for also testing the applications and web browser. This is used to protect the sensitive data which have been transferred from sender to receiver over the internet or between servers and clients. So basically in mobile applications, the communication between the app and backend server, it is secured by TLS, and in iOS the R transport security enforces the TLS 1.2 or higher, while Android has network security configuration that ensure the secure connection to mobile app data transmission. So I'll be first talking about its implementation. Basically, there are 3 major implementation of TLS, that is handshake, record protocol, and connection closure. So in implementation, in both software and hardware, browser and web browser like Chrome, Firefox, and some other browser today we are seeing Brave. These all browsers has TLS support like Apache and NGINX, and also they are configured with TLS certificate to establish secure connection. So there are some other also libraries which include in its implementation. Those libraries are OpenSSL, LibreSSL, and something I guess it's boring SSL. So yeah, used by Google. It is specifically used by Google. Where I told about certificate. Certificate basically where TLS relies on which are issued by certificate authority, that is CAS, to verify and identify the website of the enabled encrypted communication. Yes. So in handshake, the client and server negotiate a secure connection by exchanging messages to authenticate each other, agree on cryptographic algorithms, that is ciphers. Also, we can include steganography, but it comes under how to hide something behind the files. It is basically for that. And in record protocol, once a handshake is complete, the actual application is to divide data, which is further divided into records and compressed and then encrypted using agreed upon algorithms and keys before transmitted, like we discussed various SSL before the starting of this slide. And in connection closure, when communication is finished, the closing handshake is performed gracefully to terminate the secure connection and release resources. That ensures the great implementation of TLS. Now we'll be talking about the alternative, that is name of other protocols used instead of TLS. So there are some other protocols like SSH and SSL and IPsec and then TLS. While TLS is most widely used today and other protocols have been used historically in the past when there was no TLS. So SSL, it is the predecessor to TLS. Versions like SSL 2.0 and SSL 3.0 are now considered insecure and depreciated. So further there is something like quick UDP internet connection. This is a newer transport layer protocol developed by Google. While not direct replacement to TLS, it basically aims to improve the performance and security of web connections. While on the hand, DTLS, Datagram Transport Layer Security, it is itself a version of TLS for unreliable datagram protocols like UDP, User Datagram Protocol. It provides similar security guarantees and TLS, but it is adapted for connectionless communication, basically where we have two types of connection, like connection communication and connectionless communication both. So also SSH is also mainly used to for remote login and general web traffic, while DTLS is also variant of TLS, works on UDP like we have told, and instead of TCP, it is used in streaming of UIP applications. Okay, so in conclusion,